Quick revision from the last class. At the last class, we talked about AI being a system or an implementation that helps computer to simulate human intelligence and capabilities. And there are three functional things that AI helps us to do. Everything is built around these three functional areas, which is discovery, inference, and reasoning. Those are the three things that we're trying to replicate. And if you look at it, I said greater than or equal to human intelligence, which means that we want to do exactly as humans, and at some point in the future, of course, do better than humans, being able to discover new insights, new grounds, groundbreaking research. And already it is happening in different fields, in the medical field, trying to find cure for cancer, trying to find cure for different types of human ailments that still plague humanity today, and AI is really helping us in breaking grounds in this area. And that's all coming down to these three functional areas, which is discovery, inference, and reasoning. Before I continue with the slides over there, I will talk about, briefly about artificial intelligence, just to do a recap, which is stimulating human intelligence. Machine learning is a subset of AI, and that involves like algorithms that helps us to predict, to imagine, to predict, different things, to perform tasks based on data that we have, and structured and labeled data. Then we have neural networks, which is a more advanced level of machine learning. It's also a subset of machine learning, but what neural networks does is it creates different layers. And in our last class, we talked about neural networks. Let's just go back to it. So we talked about neural networks as having input layer, output layer, and the hidden layer. And every node in that network represents like an artificial neuron, and it's a regression model that has connections. And based on the relationship between that node, the nodes in that network, the weight of those connections, relationship between those connections helps us to determine what influence they have on the output. And I will now just do maybe just do a little bit of some diagram to help us with this overall understanding. So we have the old body of AI like this. Then we have machine learning, which is a subset of AI. Then we have neural networks, which is a subset of machine learning. And then we have deep learning. Deep learning is the last section of the class, which we talked about, which is deep learning now helps us better in the aspect of really learning human language, natural language processing, image processing, because deep network works based on, of course, the deep learning is based on neural networks. It helps us to learn based on layers of those nodes that we talked about. The layers of those neural networks, the relationship between the layers, the relationship between the nodes, and how information passes through those layers, and how they are processed into what we now call the human language. So I will just give you a little bit of text here. So here we have what you call the artificial intelligence, which is AI. And then here you have the machine learning, which is ML, machine learning. And here, which is after that layer, the next layer is the what you could call neural network, which is NN. And the last stage of it, which is the one we now call deep learning. And deep learning is where we are going to now expand further today, and actually now graduate finally into talking about prompt engineering. We won't get to prompt engineering if we haven't touched deep learning. That is the beauty of it. Okay, so I think that's just the general overview that I wanted to quickly, recap and talk to us about. Deep learning is a subset of neural network. It uses multiple layers of interconnected neurons to learn hierarchical representation of data, and it helps us to perform different tasks, just like I said, image recognition, natural language processing, speech recognition, and all of that. And in a moment, we'll get into how that works. So I've talked about deep learning and how it helps us with natural language processing. Now, you would realize that I'm sure all of us will have used ChatGPT at one point or the other. So let me just quickly go to OpenAI and go to chatgpt.openai.com. I'm sure you would have used ChatGPT at some point. Let's say you just how large language models work. And so this is OpenAI, this is ChatGPT. If you want to go here, just go to openai.com. openai.com. When you get to openai.com, you need to click on try ChatGPT and set up. And if you already have an account, you just click on login and it will take you to ChatGPT. But if you try ChatGPT here, and then you'll be able to get into creating an account. You can also click login. And already, because I have, if you click on login, then you click on ChatGPT. We'll still discuss all of these other functions later, which is API and DAL, which is the one for images. But for now, the one that you want to use is ChatGPT. Once you click on it, it will ask you to register. I have already registered, so I have an account. So let's say something. Just as an example, I hope you can see my screen. Let me enlarge it. After the break, when we come back in, I will switch over to GPT-4 for the proper core prompt engineering session. But I just wanted to quickly cover the basics first. Let's say, what is the name of the president of USA? Something like that. Just let's do a test. Okay, the current president of the United States is Joe Biden. Pronto, you get an answer. So that is it's a large language model, and that is ChatGPT is an example of a large language model. And you could call them, so large language models are instances of foundation models. They are applied specifically to text and text-like things. Although ChatGPT has now grown into a multimodal language model, we will get to all of those types of definitions later. But for now, just focus on the fact that large language models are instances of foundation models, right? And they are applied specifically to text and text-like things. An example of a large language model being ChatGPT. ChatGPT, and just like I said, they are trained on large amounts of data. The data, they are unlabeled, they are self-supervised. And what really happened, just like I told you in the last class, data can be anything and everything, including time, including your name, your date of birth, your eye color, your skin color, anything and everything that exists in the world today can be represented in a form of a structured or unstructured data. Now, just like I've explained to you in the last class about how we convert all of this data into labeling that is then used as a way to predict. If I go back to the here, we talked about different types of how machine learning helps us to predict. And in the last class, We talked about making a decision on whether to buy pizza or to cook at home. We talked about the different parameters that you could consider. For example, we talked about time. We talked about your fitness goals, and we talked about cost, whether it is more expensive than cooking at home. There could be different criteria that you wanted to use. And we represented these as X, all of these as X. And then we said each of them has a weight, which is importance. How important is time to you in making a decision? Or how important is your fitness goals, or how important is your cost? Based on that, we have what you call weight. Of course, there is weight. Each of them has a weight to make a decision. And then we talked about what you call the process of making a decision. So each of those parameters, then time, let's say time in this case is equal to x1. Let's say fitness in this case is equal to x2, and let's say cost in this case is x3. And then each of them also have a weight, so we could call weight equals to W, and then we talked about W1 for weight of time, we talked about W2 for weight of fitness goals, and we talked about W3 for weight of the cost. That is how important each of them is, and you could then assign values. So for example, let's say, okay, so let's say for weight of 1, we could assign a value of 1. And for weight of 2, we could assign a value of 3. And let's say for weight of 3, let's say based on how important, let's say cost is the most important factor, and say you want to give it a weight of 5, for example. And we talked about your threshold in the last class. Threshold, which is what helps you to determine whether this thing has passed, and therefore you decide whether, okay, I'm going to now buy food based on the function that I've calculated. The function will be like this. Y, which is your final decision, is now a function of x. X being the parameters. But remember that this is now equals to, let's say, for example, x1 times w1 plus x2 times w2, and then you have plus x3, let's say, times w3. And all of this, you make all of that maths, and then you then group them together. This gives you your parameters times the weight, and then let's say you have a threshold, and say your minimum score is 5. Let's say your threshold is 5, or let's say your threshold is 6, for example. And then the final score, this one times this plus this times this plus this times this minus your threshold, gives you that final figure that then helps you decide whether, oh, based on this outcome, I am going to buy pizza. And then you could then multiply these maths. You could multiply these maths for so many other individuals that then wants to use this model to make a decision whether you want to buy pizza or you want to cook at home. This is just a way of like simplifying how you reason with artificial intelligence and how this is now being replicated into many other things. So now you would wonder, we wanted to talk about prompt engineering today. Why are we talking about this? We'll get to that in a moment. I just wanted to quickly get that out of the way. We also know today that large language model is a function of large data sets. And when I mean large data sets, it means a lot of data, terabytes, in gigabytes of data that is being mined and processed through what you call, in this case, transformers. In the next slide, in the next couple of slides, I'll be putting you through what transformers mean. And then you do what you call training, which is sort of like an iteration and fine tuning of that model. In the last class, I explained something about, so let's just quickly go over that section again. Yeah, so we talked about activation function, we talked about bias and threshold, which I just explained now. And then we talked also about what you call estimating the loss function. So let's come back to this. Let's say we are applying this model to how a name is pronounced. In the last class, we talked about, so let's pick Temitope now as an example. I would use Temitope as an example. We want to use this machine learning, we want to create a model that helps us to pronounce Temitope correctly. Now, when you build that model and you are testing it, let's say the first pronunciation that is able to get after you've combined all your parameters says Temitope, right? Let's say that pronunciation wasn't correct. What this system does is it goes back. I mentioned something about back propagation and also how we use the model to check for loss function. Now, what we are trying to do is we are trying to check for what part of that neural network, what node, and what is the loss function? What is each node in that neural network? What loss? What percentage of that loss is being contributed by each node? So we check it back and find, okay, this node has contributed X amount to this loss, and that is why Temitope does not sound, or the pronunciation that the computer has generated, let's say it says Temitope, for example. I'll use a representation for that now. Let's call the first pronunciation P1. Let's call the second pronunciation P2. So let's say in the first pronunciation, we get a pronunciation and we have called it P1. We will now run it back through the system and try to find, okay, let's call the right pronunciation now P. The correct pronunciation is P. And let's call that Temitope. But now in P1, you have it as Temitope, for example. Now, A and A is what P1 is giving us. So we take it back and we run that output back through to the input. Remember that I explained something earlier about how computers process information. We will get to that. We said there is input, and we said there is output, but there is also something in between, which is where the processing works. You understand? In the concept of neural networks, you call that the hidden layer. Okay, that's where all the processing happens, right? Now, so we now have the output, right? We run this output back through the system and try to find on the layers, which part of that layer is contributing to this error, why this is giving us Temitope. Now, once we are able to identify that, the nodes and the percentage they are contributing to the loss. So that is the difference between the loss function, which is the difference between this P1, which is the output of the pronunciation one, versus the original pronunciation of Tope, which is P. So the original pronunciation is P, but what we first got is P1. Now this P1, difference between this P1 and this is the loss function. But what we need to find is what is each of those nodes contributing to that loss. And we then find that, and then we start to iterate again until we are able to reduce what you call that gradient. So that gradient is so let's go back quickly to the class, and we define gradient as the optimal weight and biases that minimize the loss function iteratively. So basically what that definition is saying is there is this weight that we talked about here, which is how important each of these parameters are in the output. Now, what we're trying to do is we will now start to optimize this weight. Maybe if we change these weights to 4, let's say, maybe if we change these weights to 4, maybe the output, the final pronunciation of Temitope will be correct. We start iteratively optimizing the weights. Of course, the computer is doing all of this until we're able to get the right pronunciation. Remember, we're trying to reduce this different loss function between this P1 and this to the barest minimum. Now, the optimal weight, right, that gives us the right or the pronunciation that is closest to this P, which is the original right pronunciation, is what gives us that gradient function, right? Now, all of that is what we are trying to do. We are trying to make sure that computer is able to give us that predicted pronunciation correctly. Now, let's get back into our presentation and go to where we are for today. So remember, I mentioned something about transformers. So we've talked about data set, we talked about transformers, and now I have also talked about iteration and fine-tuning the model to help us get the right pronunciation or the right output or the right text that we are looking for or the right answer. Now, I would go back to ChatGPT again, and I will try to explain ChatGPT, the output that it has given us, assuming that ChatGPT doesn't know the president of USA. Of course, this is like the final may not help us to actually get down into the basics. But what I'm trying to show us here is that now it has given us the president of the United States is Joe Biden. It could also be, let's say I'm saying, what is the sum of 3 and 6, for example? And it would, it would do the maths, and it will come back and say, oh, the sum of 3 and 6 is 9. That is, now that's an AI that is looking at it and is saying, oh, from my information and from what I know so far, if I add 3 and 6 together, it's going to give me 9. Now, know that this, of course, this model has been trained to be able to do this function. But in the process of training it to do this function, to be able to get 9 correctly, what has happened behind the scenes in the process of building that model is what I have basically just explained here: input, output. And then you create a model that allows you to make that prediction. And based on the predictions that you have been given in the testing mode, before it even gets to us being able to use it, the testing phase is where you check 3 plus 6. What does the AI give you? Let's say I give you 9.01 or whatever. It's just an idealization of this output that I'm trying to give you. It could also be, for example, let's find something that's maybe a little bit convoluted for the AI to understand. It could be anything. It could be, we could use an example of, okay, yeah, let's do this. I would explain something now. We may not be able to reproduce that, but an example of what I'm trying to say is, let's clear frame. Let's look at, oh no, not this one. Let's look at this. Let's look at, running. Okay, good, better. I will compare that with running. Okay, so let's move it to the side, and like based on how language works, for example, which is where we're going to next. But I just wanted to use this as a quick example. When you have running the past tense of the underlying, what you could call, let's say, stem from this. I'll get to that later though, but I just wanted to quickly explain something. You have run. From this, you have run. Then you also have run, which is the past tense. But AI also understands that because you can shorten this running to run does not mean that if you shorten better, for example, it means something entirely different from bet. How does AI know this? That better is different from bet, and that running, run, run, they all stem from the same word, run. Then you have run, which is the past tense of run, and you have running, which is the present continuous tense. That understanding comes from the fact that it has been trained over time and now understands the relationship between these words. But that process of training it and for it to understand it is what I've just, like explained to you, which is you have a big set of large data, you have the architecture, which is transformers, and then you have the training, which is the iteration and the fine tuning. Now, size and complexity of LLMs, just like I explained, big data sets. You can have it trained on as much as petabytes of data. Imagine that you have 1,000 bytes equals to 1 kilobyte. Now you have 1,024 kilobytes gives you 1 metabyte, right? Megabyte. And 1,024 megabytes gives you 1 gigabyte. And now 1,024 gigabytes gives you 1 terabyte. Now, GPT-3 is trained on a corpus of 45 terabytes of data. That gives you like how much data is used in processing and training AI to be able to understand and now to be able to respond to you when you ask a question. It means that there are loads and loads and loads of data in different texts, in different contexts has been passed into it, and it has now learned all the relationship between that data. Remember, I told you data means anything and everything. Anything and everything can be represented in data, and AI now able to understand the relationship between all of those data to now give you an output. Now, what are transformers? They are generative pre-trained models. Like I said, GPT-3 is an example. It's basically transforming data or input from one sequence to another. I will break down all of that. But basically what transformers has helped us to do is to be able to now write in a human form. So it can basically generate text that resemble what a human would have written. And that is what is enabling us to get to that level of reasoning and to be able to really write in a way that a human like processes and writes information is what we are now going to be looking at. So how does transformers help us to translate? Now I will go into back to my the board, and we will do so I will like separate it a little bit and break my screen a little so you can see both as I'm explaining side by side. So let's clear the frame and let's write again. So I said in a transformer model, you have what you call encoders. Okay, so let's give it the text encoder. Then you have what you call decoders. Now, what happens to language and how ChatGPT is able to help us understand language is that now when you type your text or you send it a text, what it does is text. So I'm going to do a drawing here. There is what you call encoding. Now, the process of that encoding is to break down that text into a form that can be understood by AI or by computer, right? And after it has encoded your sentences, so let us say, let us type something, for example. Jollof rice. I want to use jollof rice as an example. This is a very relatable one. I don't want to start an argument of who makes the best jollof rice between different countries. But jollof rice, I will use jollof rice as an example. I will say, I want to cook jollof rice with rice, curry, with rice. I will start by boiling water, then parboil, okay, the rice, and add seasoning, okay. Oh no, so then I will prepare tomato sauce, okay, with seasoning like curry and thyme. Let's stop here before you start salivating. But the idea is that I wanted to give you a context. Now, this is text. For example, how does encoding works in this case? In this case, this text is broken down into portions, into words that each of these represents. So the I is one, want is another one, to another one, cook another one, jollof another one. Now that encoding is done based on this, and then each of those words represent something. For example, jollof rice in this case is a food, is a food type. But how does it know that jollof rice is food? Because in its training data sets, jollof rice would have been represented, rice would have been represented as a food type. And then jollof would have been represented as a type of food or as a type of rice. Now, each of these words are then broken down and then represented in numbers. And that is what the encoding helps you to do. And then you have the decoder that then processes. So this information then goes from the encoder and passed into the decoder. Now, remember that we talked about this, the transformer use sequence to sequence learning to predict the next word. Now, what it is doing is it is processing this information, right? It's processing this information through that encoder and that decoder process. And what it does is it will basically break down and then generate relevant encodings for each part of that input sequence, because it's basically processing that input, it's processing that information based on the items that represents that encoding, and then it's been then processed further. And then what you now have is there's the decoder part of it that now understands based on the inputs that you've provided, in through the encoder. And that's what transformer is now doing. Now, it has broken this text down into small portions. It's now understanding each word and how the words are related to one another. Now, decoder that, based on that input, now understands, now decodes all of that input and says, okay, there is rice, there is jollof. So there is a food that is being cooked here. But there is also seasoning. And once it sees curry and thyme, it knows clearly you are trying to make what you call, it knows that this is a recipe. So it knows that this is a recipe and can already predict what you are trying to do. You are trying to cook jollof rice, you are writing down your recipe. And based on that, if you ask further question, now it is trained all of this. And remember that I said there's training, there's a large data set, all of these data sets. So when you type something into for example, ChatGPT, what it's doing is it takes that input, processes it, and then gives you an output based on the information you have provided, checked against the data set that it has been trained with, and then decodes your information and says, hey, this is what you're trying to do. Now, there are other types of machine learning models. There is the computer vision model that is used for self-driving cars and facial recognitions, and there is some that is used for food processing. Now, remember that this is based on text, but there is also computer vision that is based on images. And all of these, remember that all of these are all part of what we call the deep learning process. This is much better than the basic one that you could talk like regression and stuff. This is a more advanced model, which is neural networks. All of these are built on neural networks. And of course, it helps us to do a lot more, like facial recognition, much more than just text. There is also, of course, I talked about natural language processing, which is text translation and text summarization, and of course, chatbots that we use today. There are recommendation systems as well. If you go to, for example, Netflix, or you're listening to your Apple Music, and you listen to a specific set of genres. Now, based on those ones, it can basically say, if you have listened to this type of music and listened to this type of music, you probably like, let's say, for example, you have listened to Afrobeats. Let's say you have listened to, you can type in the comments if you have any the types of Afrobeat music that you know, but I do know about, let's see what you have in the comments section. You can type in the comment section. Let's see what we have there. Let's say Afrobeats. You can also write something about gospel music also. Okay, this guy says City Boy. Let's see. Somebody said Burna Boy. There is also, you can post, but I will just continue. Now, once you listen to a specific genre, then AI can know that, oh, it seems that you like Afrobeats. So that's the first thing. Then the next thing is, it seems like you like Burna Boy. If you like Burna Boy, you are probably likely to also like Davido. And maybe you might also like Wizkid. And maybe you might also like maybe Mubad. And maybe you might also like different types of Afrobeats, and it starts to give you suggestions based on what you have watched. And also sometimes it looks like, how many minutes did you listen to City Boy, or how many minutes did you listen to, for example, Wizkid? And we'll then use that to iteratively make suggestions to you based on your interest. So there is also what you call the reinforcement learning models. Quick one. Also, if you watch Netflix, if you have been watching, for example, war movies, it will probably be recommending movies that are similar to that, where they shoot maybe a lot of guns, a lot of action movies. And if you are the lover boy or the lover girl, and you like the love music, and it will probably be giving you those some of like emotional content. Those are the kind of music or films that it will be recommending for you. And if you are the type that likes, for example, series, it would probably, once you open your Netflix app, what you will be seeing is series, recommendation of series that are similar to what you've watched before. So the next time you open your Netflix or the next time you open your Apple Music and you see songs that are similar, that you always like, you play one, gives you another one that you really like. It's basically AI using how you have been interacting with Apple Music and knows that, oh, you have listened to Burna Boy, and you have listened to Whiskey. You would definitely like to listen to Davido. It's just that simple process. There's also the time series model that predicts weather. So if you open your app and you open your weather app and you see the weather suggesting that, oh, it will probably rain at this time. What it's doing is basically time series based on the weather at the moment, based on, for example, the wind speed, based on, for example, humidity. All of those data is being compressed together, and it would have created a time series based on the time of the year. What happens at this time of the year? What happens at this month of the year? When the wind is blowing at this speed and at this temperature from this direction to this direction, what is likely going to be the reaction in the atmosphere? What's the level of water in the atmosphere? What's the temperature at now? And then it starts to make a prediction based on what is likely going to happen by compressing all of that data over time. And that's why you realize that more as time goes on, the prediction quality of weather is now weather data can tell you exactly what's going to happen at around 10, what temperature will be like at maybe 12 p.m., at 1 a.m. It can do all of that because it knows a lot of data. And by processing that data, it's able to create a time series and can then predict what's going to happen. It's also used in trading. For example, if you hear somebody saying, oh, they can predict what the stock price of, for example, Dangote, or for example, Tesla is going to be, or Microsoft is going to be at this time, it's just built on time series. Are they perfect? No. But are they good? Well, it depends on how each person is using those models to make predictions. And like I said, each model is designed specifically to solve specific problems. You cannot generalize it. So, having said all of this, now I want to dig prompt engineering for you. Now, the reason why I waited this long to actually do prompt engineering is because you can't do prompt engineering without having understood how data is being processed in the back end. Like when you send a query to, for example, ChatGPT, what does ChatGPT do behind the scenes? That is what we want to learn now. This is just a quick check with you guys, and just to understand that what has been happening. Are you following, or have I been shouting to myself? Is this something that you are understanding? Please, I would like to read your feedback. It would help a lot, because what the feedback you provide, I will add it into how I prepare for the next class. Do you understand? Thumbs up if you understand. Please type a text if there's something you don't understand yet, and I can provide more context or provide more explanations. But I really, okay, somebody said, shed more light on encoding and decoding. What would you, if you can be specific, that would be helpful. If you can be specific, that would be helpful. Okay, somebody says, can we get recordings to learn more? Yes, I will definitely provide the recordings. What I'm doing is, when we record, we need to process that information. We need to, remove um, noise from it, and then we then publish the rest. But the first class, the video is ready. Is going to be uploaded today. Today's class may not be ready until like Monday or Tuesday, but definitely we're going to publish. Um, okay, good. The recording, definitely you're going to get the recording. I am going to provide more clarity on encoding and decoding. So class, please, one thing I would like to ask of is that I might, likely extend the class by just a few minutes more than what we had initially published or advised you, because it seems that, especially because I needed to dig more into the natural language processing and foundation models before I actually dig into prompt engineering. So the other time I went into ChatGPT and I typed in, what is the name of the president of USA? And it responded by saying the name of the current president of the United States is Joe Biden. That in itself, that process of typing this, what is the name of the president of USA, is basically prompt engineering. But is that the best way to get information? No. And we will get into that. So what is prompt engineering? Prompt engineering is just a process of constructing queries for AI, for generative AI. You construct your query, you pass it to the AI, and AI gives you a response. That is prompt engineering. No more, no less. Now, remember that before now, I put you through what we call, language processing. I put you what you call transformers, how ChatGPT processes your information, how ChatGPT uses what you call a transformer model, which goes through encoding information and also decoding information. And I also talked about large language models being consisting of three primary concepts: large data, architecture, that architecture being transformer, and training. Training in the sense that training is done on large data sets, of data that is existing on the internet. So the data comes from multiple and millions of sources. They just imagine that everything that humanity knows, basically, that is what AI already has some type of information about. Does AI know everything? It depends on what you define as everything. But in reality, in the real context of things, AI knows everything we already know as humans. The question is, are you asking AI the right question in the right way? And that is where prompt engineering comes in, which is writing, refining, and optimizing your prompt in a structured way. So let me just give you a, so I believe we will get to this encoder-decoder relationship soon, but let me just provide the text. So you're writing, you're optimizing your prompt, structured manner. Let me enlarge it. So there has to be structure to it. To elicit the right and to seek the right information. Okay. And I would put also contextual also. Now, why all of this? Why? Because AI knows so much, but also knows so little in the context of things, right? Oh, I move this out. Okay, back in. Good. Now, AI knows so much, but also knows so little in the sense that what I mean by that is if you don't ask it the right question, then it will basically give you garbage, right? Let me give you an example. When you use the word running, now running can mean a lot of things. Running can mean a race, a track race, right? Let's even throw it to everyone. What's the meaning? What does running mean to you as as a person? Let's hear in the group chat. Thank you for that question. I see that somebody said, I'll take note of that. What if the text is not in data sets? Go on. Somebody said sprint. Somebody said move with speed. Any other ideas? What does running mean to you? Avoiding in conversation context. Yeah, good. Somebody said, good. So I get that. Let's bring it in here. So we wanted to talk about running. Somebody said running could mean let's look at it. Size normal. Let's call it's too small caption. Let's call it normal. Okay, good. Yeah. So somebody said it could be a track race. It could be running from conversation. Somebody said it could be a competition. In fact, I would say it could be an election. Good. Let's see what other people have also said about running. Somebody said a running nose. Thank you. Another said to be in motion, to move quickly from one place to another. Great. Thank you very much for your contributions. Let's go back to our board. Somebody says a running nose. Now, just now we have defined we have maybe 15 definitions of running. Imagine now, let's go to computer. Let's go to ChatGPT, which is a large language model that is supposed to know everything. What is the meaning of running? Let's hear what ChatGPT says. Running refers to the act of moving swiftly on foot by taking steps. I would like you to read what ChatGPT defines running as. Running refers to the act of moving swiftly on foot by taking steps, typically faster than walking. It's a form of physical activity where a person moves their legs rhythmically, allowing them to cover distances more quickly. Running is often done for exercising, sports, or as a means of transportation. It's a great way to stay fit and healthy while also enjoying the outdoors. I laughed because when he says, "or as a means of transportation," this is a sample. In Nigeria we say "sapa." This is a sapa level of transportation. I'm sure. Let's ask. In my definition previously, I said that a large language models can also write jokes. So let's ask ChatGPT to write a joke. Write a joke about running in Nigeria. Let's see if it's able to write something. Why don't runners in Nigeria ever get lost during a race? Because they always follow the Niger navigator. I don't know what that means, but that's a very dry joke. We will get back to making that joke better later. But for now, let's just know that it says that why don't runners in Nigeria ever get lost during a race is because they always follow the Niger navigator, whatever that means. But ChatGPT can attempt to write a joke. That was just a very bad joke. But you can see that the definition of running only captures race. It doesn't capture running from a conversation. It doesn't capture competition. It doesn't capture election. It doesn't even capture running nose. What that means is if you type a general question, ChatGPT will process your information and will pick the most likely response. And remember that we talked about regression models the other time. I know everybody's not a mathematician here, so I won't go down into breaking what regression model does. But you see that formula that we were creating the other time that is helping us to see the relationship between the parameters for making a decision, the weight for each of the parameters, and your threshold, and the loss function, and activation function. All of those functions, they contributed into making a model that we then use for making a prediction. What is going to happen is after creating that model, and you ask ChatGPT a question, ChatGPT is basically going to run your query through the model and basically give us a response that has the highest probability of being right. So it's all based on probability. Even your regression models eventually comes into a probability. It's a percentage, right? What you get is actually an outcome or a result that is probable. Now, in the estimation of that probability, you can then get different forms. Like it can calculate it now, and it can be maybe 99.95, and this is the way it should be picked. And then another time you try it, it gives you another answer. That is why if you try this joke again, I just told you it's about probability. If I try this query again, it's most likely giving me another answer. So let's try again. Exactly the same query. Let's give it again. See the answer. It says, I asked you to write a joke about running in Nigeria. And it says, why do runners in Nigeria make great comedians? Because they always know how to run with a good punchline. You see, he's just trying to create a very dry joke. But the point is, he gave a joke here, and the joke is completely different from the joke that is coming here. That is to tell you that, to corroborate the fact that it works based on probability. And because you want to get the right answer, even within the context of that probability, there are a few things that you must always do. And that's why you have prompt engineers whose basic responsibility is to continuously monitor and update prompts, because as the model learns further, as it improves, as they do all of these things, what they are doing is they're consistently monitoring it and updating prompts to be able to get the right response. They report the findings, and they are thought leaders in the field of generative AI. Basically, that's what a prompt engineer does. But why should you do prompt engineering? And we will do that in the next slide. Because AI is simulating human intelligence, we therefore want to be able to control the output. If we don't control the output that AI gives us, we may definitely run into problems. For example, AI should know that you can't do some jokes, for example, or you should not be doing some jokes about, or maybe AI doesn't know, but you have to be able to control it so it doesn't do bad jokes about religious entities or religious personalities. Why? Because those are cultural norms or cultural contexts that you have to be careful about. So you have prompt engineers that are constantly working on these things to ensure that AI doesn't give you bad response. Now, what does also a prompt engineer does? As I have different things I do with AI. For example, writing CV, writing my statement of purpose, writing my cover letter, doing all of these things. When I'm doing all of these functions and also doing it for other friends and clients that I try to work for, what I ensure is that I'm crafting my prompts to be able to give me the desired outcomes that I'm looking for. Prompt engineers also enable AI to provide accurate and engaging responses. It also helps architects and developers to maintain control over AI so that AI doesn't go out of hand. Because basically, as AI learns and knows better, like I said, because it's able to discover and make inference and also reason, you have to control it because these three things can make AI get out of control. And that is the job of prompt engineers to put it in check. Now, linguistics, how does it come in the context of prompt engineering? Let's do a basic dive. Now, we know that linguistics is the study of language in various forms, in various aspects. Now, AI understand, linguistics helps AI to understand language nuances because it is based on that one, we're able to craft effective prompts, and two, that AI understands the prompt based on the context. So because linguistics is general, therefore it's important that you as a prompt engineer, you craft your prompt within the context of linguistics so that AI can respond to you also within that same context, which means you have to know what you're looking for. Now, we talked about computational linguistics, which is exploring how computers process human language. There's also physiolinguistics that, of course, different types and forms of linguistics. But remember, we just talked something about, computers processing human language. How does it do that? How does it understand your language when you type something in and is able to process that language into a form that, remember I said, encode and decode. That is the context that we will get to now, which is language models and how they, process your information. Now, when you write text, what AI is doing is it is basically breaking down that text. Let's go back to what we wrote here. I want to cook jollof rice. I will start by boiling water. I will then parboil the rice. I will prepare my tomato sauce with seasoning, like curry and thyme. Now, the first thing that AI does to be able to understand this thing that you have typed is to break down each of these texts. And that process is what you call tokenization. So I need to break it down a little bit. Let's see if I can clear this part. Uh, okay, so let's clear frame. I will type again. We have tokenization. What AI does is when you write or type a sentence, it tokenizes your sentence. Example, I am running home to meet my, what are you running home to meet? To meet my friends. Nice. Okay. Okay. To meet my family. Let's put it this way. So, what does AI do when it tokenizes your sentences like this? It breaks it down into, picks each word, and then finds and picks the relevant, the context of your word. So it sees home, sees running, sees home, sees meet, and sees family. By breaking it down into words, right? I think from what we know so far, one token is like equals to 4 characters. I believe so. That's, I think, based on ChatGPT now. Is about 4 characters, which is say 0.75 words thereabouts. I think so. So this is like an approximation. So what it does is it tokenizes this. This is just a brief of a representation. So you have I plus am plus running plus home. And this is how he's able to, now it then starts to understand, after tokenization, it then starts to understand the parts of speech for each of this, right? So so there is a tokenization, there is what you call, I will go to get that, to get stemming. There is also what you call lemmatization. And the final part, which is of course now getting the parts of speech. Now, this, let me, so I will delete this part now so you understand what this means, but let's put tokenization here. Let's put stemming here. Let's put lemmatization on this side. And then I'll bring this one down to this side. Okay. So good. Let's bring this here, and then let's bring this here. What we are doing with natural language processing is stemming and tokenization. I mean, and what tokenization does is it breaks it down, and then after breaking it down, you have 2 important parts, which is stemming and then lemmatization. What is stemming? What is lemmatization? A clear example is when you have running here, and let's put the other time I was talking about betting. Right. Now, it knows that running stems from run. So let's come here. After breaking down the words into, the text into, tokens, it then starts to look at each word, what they represent, what parts of speech. Is it a verb? Is it an adverb? And after understanding that, now understands how each word or each part of speech is constructed to form a sentence. All of that, and those are rule-based, right? So linguistics has been around for ages. So basically, we understand linguistics, we understand how words are constructed, and of course, we now pass that information to computer and say, this is how a sentence should be constructed. You have the verb, you have the pronoun, you have the you have the noun, you have the pronoun, you have the verb, which is in different forms, present, past, present continuous, and this is another noun. So understands how these words are being connected to each other, and then is able to form a context. Now, that stemming is actually knowing the stem for each word, which is, what a stem means, like literally the stem of a tree, and how, so if you have different branches out of the stem, basically, that all of these branches came from one stem, which is run. And from this run, you can have different forms of run. So, for example, you can have run. You can't say runned, right, as a past tense. You understand? Just like you have, for example, cook. AI knows that there is cook, but there is also cooking. And it knows that the past tense of cook can be can, the same way that we put running, to put run as run. It knows that cook and can doesn't mean, it means nothing. It knows that the past tense of cook should be cooked, right? Now, already, it knows the stem, which is the stem is cook. But lemma, which is like the dictionary meaning of that word, it knows that cook is, when you're cooking food, is food related. But cook can also mean something else. Like when you say cook him, like when you say, or cook a story, it knows that when you're cooking something, you're making something. So the understanding of that dictionary meaning of that word within the context that you're using it is what is called lemmatization. And that is what AI also does. Knows the context and knows the meaning and knows what you are trying to do with it, and also understand the parts of speech. So all of these feed stemming and lemmatization, all they feed into that part of speech. So I've already given you everything about natural language processing and how it works. And basically, now I've talked about tokenization and how it helps us to recognize all the entities that are involved, which is I am running home to meet my family. And each of these entities, they represent something. And by breaking them down and processing each token based on the stem and their lemma, right? So there's tokenization, there is named entity recognition. So I can put named entity recognition somewhere here. Let's put the text here. Named entity recognition, let's call that NER. I can put it somewhere here, right? And let's put it here. And the three of them feed into like the parts of speech which they represent, and then processes them further. So this is what you call the natural language processing, the techniques of understanding your sentences for AI to be able to process a response. That is natural language processing. So I asked for extra few minutes the other time, and we'll get into that. So The reason why I needed this extra time is because we just can't go into learning everything without understanding all of this and how they work together. So this is just what I've explained: tokenization, breaking down the words; stemming, that is this reducing the stem, the words to their roots, to the stem where they come from. Running came from run, that is the stem. And lemma is reducing words to the dictionary form, taking into account the context of that word. That is the context in which that word is used is called dilemma. And by understanding these four techniques is what is all combined together to help us to process. That's what we call natural language processing, basically. Like I explained here, tokenization, stemming, NER, and that's named entity recognition plus the lemmatization. All of them form and help us to understand the language that we're using. And then by understanding this, then you can have different use of natural language, because now you have broken it down into something that the computer now knows, right? And after now that you have broken it down, computer can now combine it and says, oh, okay, so you're talking about running home to meet my family. By understanding that, you can then ask computer other questions based on that text and based on what it knows, right, about the text or the information that you're trying to process. So here I tried to give you a view of what AI is doing with your word. Output, input, they're all text, but the output will be for named entity recognition, that would be entities. And for tokenization is token. Break them into text into smaller units. And here is stemming. That stemming is reducing them to the root form. Then lemmatization is using the context and dictionary meaning. Now, to give you a more, like what that entity is doing for you is, for example, an entity here is home, family, running, right? Those are entities that are in this and actually this name entity recognition, in fact, is one of the most important aspects of writing with AI, and I will quickly show you all of that in a moment. So, but there's just challenges of natural language processing. So, like ambiguity, running can mean many things. I talked about cultural and regional variations, and I talked about sarcasm, irony, jokes, religion, and also like out of vocabulary words like Niger. Niger is out of vocabulary, right? So it can also pose problem for NLT, especially when you use one like SAPA now. SAPA, I'm not sure AI knows SAPA, right? But let's check. Let's check if ChatGPT knows what SAPA means. What is the meaning of SAPA in Nigerian context? So, all right. So let's see what it does. Good. So actually, it knows SAPA, which is a Nigerian slang term that is used to describe a state of financial hardship or lack of money. When someone says they are in SAPA or SAPA day, it means they are going through a period of financial difficulty. Okay, good. In a Nigerian context, yes, it does know what SAPA means. But what I'm trying to say here is that there are scenarios where it may not necessarily know what SAPA means. And if you ask it a question about SAPA, it may completely get lost. Or if you ask it about, something that is not a slang that is not generally known, they may completely get out of context and start giving you garbage. So there are different types of models, like we've talked about. There is GPT, there is BERT, there is Lambda, there is Palm, there is Bloom. There's so many of them, so many of them. the one I like the most. And each of these models have different use cases and different functionalities that you need to be aware of. We will get to that maybe sometimes. Now, best practices. When you're writing your prompts, what should you be aware of? Now, when you're writing prompts, good prompts, of course, they help us to save time and help you to avoid wasted tokens. So you need to think about intuition. Sometimes when you're writing your request, you need to intuitively make that request, thinking about knowing all of the things I've talked about, especially the fact that AI may not know the context. AI may not know what you're trying to ask for. So you have to provide detailed context. Now, I talked about opaqueness also. Like, running can mean a lot of things. And so if you write a prompt about running and you don't provide more details about the running you're asking for, then AI will be giving you a response that you don't necessarily want or that you're not looking for. Writing clear instructions with details in the query. Example here. When I was asking this question, I said, what is the meaning of the slang? Now, remember, I've told it I'm looking for something that is about a slang. I'm looking for Sapa. And I'm looking for Sapa in Nigerian context. Because Sapa may mean something else in another country, or in a different language, or in a different culture. Maybe Sapa may mean even robbery, right? So you have to be specific what you're looking for. Your query has to be clear and simple. Now, there's also what you call persona. And I would like to dwell actually on persona and entities. Now, the reason why I said persona and entities is because those are the bottom line, the underlying factors of AI that helps you to know that, in fact, it is what defines how well an AI has, for example, has been trained and how well an AI is able to respond to you. Remember, we talked about named entity recognition. Now, entities at the bottom line. If you get your entities right, your writing will be fantastic. So let's talk about, persona and why persona is important. Recently, yes, I wanted to show you this custom instructions, and those are part of the places where you have to really actually talk about persona. Custom instructions was something that came up recently from ChatGPT, and of course, I have been using persona, personally before. For clarity, I personally use ChatGPT. I use a lot of AI tools, a lot of them. I think I use more than, at the last count, I've used and I'm actively using more than 20 of them. But the two of them that I use for my everyday task is Claude and ChatGPT. So notice that when I'm going to open my Claude, I'm opening my Claude from Opera. Free tip, download Opera. And when you are downloading Opera, download Opera that comes with a VPN. If you look at my screen, you will see something here in my screen. I believe my screen is bold enough. There's VPN, a blue icon here. Make sure that you download Opera with VPN. How? Just search for download Opera. Opera browser with VPN. I didn't tell you how to hack this. I'm just giving you ideas. So this is what you're looking for, browser with VPN. So I will open it and post it in the group chat. So you can also use it at your own time. So let's put it here. Good. So Opera with VPN. Now the Opera with VPN, it will help you to use ChatGPT and also any other AI tools. But what I'm particular about here is the VPN. Because if you are going to use Claude, Claude is restricted to a specific set of countries. Definitely, if you are not from US, if you are not from UK, and maybe one or two other countries, you may not be able to use Opera. But if you download, you may not be able to use Claude. Now, if you are writing, Claude is one of the best. It's not a paid advert, but I can tell you I've used it, and I will show you a few tricks just in a moment. So when you download it, install it, and after installing Claude, what you should do is you will come here, somewhere here at the top right corner, click on these 3 lines. There are about 3 lines around this corner here. You need to click on it and then scroll down to VPN and click enable in settings, and then follow the instructions, right? Once you do that, it will enable VPN for you. And this icon here, VPN icon here, has to be, I think, blue or purple. So basically, once you do that, you'll be fine. So let's open our Claude. And I use Claude every day. Like every day, I use it to apply to jobs. I use it to do, everything and anything. I'm currently working with some group of Nigerian potential researchers and PhD researchers who wants to go and conduct research in the US and North America, and I'm helping them to optimize their CV and helping them to write their the best what you could call their PhD application and the SOP and everything, writing the best one. And of course, the good part is automated. So once you have it, you can always use it. So anyway, we'll get into all of that later. Now we want to get into Claude. And I was talking about entities and persona. Now, setting your persona is one of the best things you can do for yourself. How persona works in different tools, they differ. How you use persona in Claude is going to be different from how you're going to use it in ChatGPT. Why? Because ChatGPT allows me to pass custom instructions that is permanent, and I can set it there. So there I set my persona, right? So let me show you how you set your persona in ChatGPT. Once you open your ChatGPT, whether you are using the paid or the free version, if you are looking at my screen, please, I hope you can see my screen. Go to this bottom left corner and click on this. Once you click on this bottom left corner, there's three buttons here that you need to click on. Just click on that button and click on custom instructions. And this is where you set your persona. Then it will ask you just a basic question so that it retains this in the memory, and then it knows that, okay, when I'm going to respond based on any query to myself, Oladotun, this is what I need to know about him. So I said in my own custom instructions, which I can share with you guys, so you can also use if you want, I said make sure that you don't follow AI pattern, but articles should be really simple and should make sense, right? You can even put full stop here. It should be as written by a grade 8 level writer, aiming for a flash reading ease or ease score of 66. You always bold the key entities in your article. Okay. Now, try to understand. I've already told it that whatever response you are going to give me, make sure you make it very simple and easy to understand for a grade 8 level writer. See what I also put there on where you're based. You're currently based in US and you write for the US audience. I can change this all the time depending on how I want to write. So for example, if I want to write a specific article tailored to, say, professionals, I can come in here and say, your articles will be for, let's say software developers. Okay, or I could say it could be for lovers seeking counseling. Or I could say your articles, so now that's setting persona. Remember that here I'm setting persona for myself and also persona for the audience that are reading my content. Now let me delete that part for now. Now, I also put it here, and I indicated that it is important. I said your response will never include warning. So normally, sometimes when you ask AI question, we say, "Oh, as an AI, whatever, right?" I can set my persona and set how my responses should be. So you can see how would you like ChatGPT to respond. And I said your response will never include warnings, disclaimers such as "but not limited to," as an AI, as a large language model. You can get all of that from AI all the time, giving you some gibberish. What we are doing here is we are constraining it to respond to us in a specific format. On your profile and general capabilities, your response should be informative, logical, and actionable. Your response should be positive, polite, and engaging. Your response should avoid being vague or off topic. Now, remember that I'm giving it, and now I'm giving on your ability to gather present information. Yeah, okay, this one is also very important. You should always reference factual statements to the answers you provide. You can leverage information from multiple sources to respond comprehensively. And then you save. So, bonus tip, I can just drop that in the group chat so you can, copy it and use it as you want. So those are my custom instructions. And for let's say for your how would you like ChatGPT to respond, I can copy it and give you a sample of what I use. Now the thing is, you can adjust it. You can put in more custom instructions, right? Based on your own needs. Now I have created it based on my need, and I always adjust it. This is just the current state of it. If I need to write an article about something, I will go in there and adjust it again. That is how I use it. Now, let's go back to our presentation. I'll finish in 5 minutes. So there are a few other things that I wanted to talk about. Now, the thing is, we are not going to again finish this presentation. This is just the last slide I'm going to use. There is still a bit more in the construction of those prompts, and also then give you access to my prompts library and all of that. I will do that in the next class most likely, but for this class, I'm just going to round up with a few things. One, You need to know that your specific prompts yield more accurate and desired responses. Now, don't try to write so long prompts. It doesn't help you. Keep your prompt simple and concise and straight to the point. What do you want? I give you a simple model that works for me. So I hope everybody knows this. I will clear frame. Prompting model. Okay, I'll give you what works for me, right? So the first thing is task. What do you want the AI to do? After you've given it the task, you could have instructions. Instructions. In that instructions, you give it you set the persona. You set the how you want it to write. You could even set the tone. So you could set the voice. Now, when I talk about persona, you should write the persona, the writer persona, and the audience persona, right? It helps. So how to write the tone. When I talk about the tone, that is, do you want the tone to be active or passive? I recommend active always. Actually, I always recommend active, except it is explicitly like you really have to write in a passive tone. Always use a tone that is active. Your voice, you can choose the voice that you want to use, whether you want to use the first person. When I say first person, where you're writing I, my, it's you. That you are sharing your own personal experience. Now, the type of voice you use depend on like what kind of content are you writing, right? So you have to decide whether it's the first person, whether it's the second person, you, yours, right? Then there's also the third person. Here you're talking about them, they. Then there's also the last one, which is professional, right? A professional voice, like if you're writing you want to remove, so you silence the person and you promote, like when you're writing and you're putting one's perspective, one's opinion, rather than using my opinion, you turn it professional. So you use the professional voice. Then you need to also, so notice that these are all still under instructions, right? So your instructions captures all of this. Let's the AI know. And also, you may want to state your okay, maybe I'll take that in next time. So task, style. Now, when I talk about style of writing, you might want to indicate whether you want to write as, and usually when you're, be careful when you're doing your style of writing and you're giving it the style of writing, you want to indicate whether you want it to write like a poet, a known poet, or you want to write like a known artist or writer. Do you want to write in the form of a Shakespeare? You want it to sound like a Shakespeareish language, or you want it to sound like Wole Soyinka, or you want it to sound like Chimamanda Adichie, or you want it to sound like name the different authors, the popular authors, either in the US or in the UK. You have to be very careful in choosing this. Make sure you're choosing a name that is really, really popular. And therefore, the AI would most likely have been trained on it. Or you want to write in the form of New Time magazine. You can even choose that and say, write in the style of Time magazine. So in this case, you are telling AI that I want my writing to sound as if it has been written by Time magazine, such that when somebody reads it, the writing, the structure, and construction of your sentences will look like Time magazine. That's something. That's if you're writing an article. But task, you need to state the task. What do you want to do? Do you want to write an article or a poem, or you want to write a prose? What do you want to do? What task? Or you want it to calculate something? What do you want to do? Task. Now remember that each of these terms or each of these features will be used depending on what you are doing and the task you're trying to complete. So you actually need to know what you're trying to do, and that would inform which of these tools that you're going to use in your prompting model. So your style of writing. So after your style of writing, then you need to state, like, for example, your limitations. I'll give you an example of limitations. How many words? What's your word count that you're looking at? Do you want it to use bullet points? Do you want it to also give you a table? So those are just examples of limitations. This is like a general overview. There is the last two sections of this presentation that is supposed to take care of actually now writing going through the prompt styles. So there are two things that we are going to have to look at in the next class, which is prompt styles, and there's something that is also missing here. Okay, so there's prompt style. I wanted to touch on something on NLG, but we may maybe talk about that later. But prompt style is missing, and I wanted to also touch on vectors, embedding, and vectors. Okay, these are the last aspect of this presentation that we are missing, that I would like to cover, and we'll probably move it to the next class. Unfortunately, this is just how vast, it's just to show you how vast prompt engineering is, and like the massive amount of information you need to know to be able to actually do prompt engineering correctly. And that will bring us to the end of the class today.